Hello, problem solvers. Colfax Math here. Today we're going to go over bivariate statistics, how to run regressions, what the Pearson correlation coefficient R is about, and which regression is the best fit. We're going to run 3 regressions: linear, nth power, and exponential. Let's say this is our data set right here. Y depends on X. First thing I want to do is enter my data. So I'm under the stat key right here. I go stat. Want to edit first. I hit enter. I go to the top of the list, hit clear, and that'll clear the previous list. Then I'm going to enter my data points: 2, 3, 5, 8. Over in my other list, 20, 22, 28, 30. Now that my data is entered, I'm going to go back to stat, and I'm going to run a calculation on it. I'm going to run a linear regression. So I'm going to run a linear regression with the general equation y equals ax plus b. So I hit enter. I am using list 1 for x, list 2 for y, and I hit calculate. And it gives me a R value. That's a correlation coefficient. So my R value here is 0.953. That's a pretty good R value. The closer to 1 or -1, the better the fit. If you're not getting that R value to pop up when you run that regression, you have to go down here to catalog. So second 0, catalog pops up. Scroll all the way down to diagnostics on, and then you want to turn your diagnostics on. So there it is right there, diagnostics on, enter, enter, and now you could clear it. Okay, so we ran a linear regression. We're going to go back to stat. We're going to run a calculation. Now we're going to run an exponential regression. So number 0 here is exponential regression. Enter, same list, calculate. So my R value here on my exponential regression is R is 0.944. Pretty good fit, but further from 1 than that. So linear so far is a better regression. The general equation here is y equals a times b to the x, where a is 18, so it would be y equals 18 times b, 1.07 to the x. That would be my general equation. That would be my specific equation. Let's go back, run one more statistical calculation on that data. Let's run an nth power regression. So I hit enter. I go through that chart again, and I run my nth power regression. It was just power regression. The general equation is y equals ax to the power of b, right? So there's my general equation. Then here's my values for that equation. So y is equal to 16x to the power of 0.313 with an R value of 0.98. So I ran 3 regressions: linear, exponential, nth power. R value for linear is 0.953. R value for exponential is 0.944. R value for exponential is 0.944. R value for nth power is the one closest to 1. This is the best fit. My general equation is that. My specific equation is this. So with this specific equation right here, with that really good R value, I can use that as a model. So let's say I had a value like 12 in here for x. What would my y value be? Well, I would just take that value of x and plug it in here, right? So I got to do my exponents first. So I go 12 to the power of 0.313 equals times 16, and I get 34.8. So this value would be 34.8. And that's kind of the whole power of running regressions, but you have to be able to interpret it using the Pearson correlation coefficient. So there are two pieces. The R value, how well the data is correlated, and then running the regressions, coming up with your specific equation.